right, guys. So I am going to be walking you guys through the steps that I took in order to get the regression for Ohio. So for those of you who are in AP Stats or who remember this from Algebra 2, a regression is like essentially you are coming up with like a line of best fit. So it's pretty much like you have a scatter plot and you are drawing a line and you're using this line of best fit to potentially like predict future values. So I'm going to be using Ohio. So you would say, okay, you're going to choose one of these states, and then you're going to go to this 270 to win website. This is going to give you the historical data from 2000. So since I'm picking Ohio, I'm going to come in here and I'm going to say, all right, we're going to go to Ohio. I'm like saying the alphabet in my head. And when I come down, I'm going to see that in 2000, it was 46% Democratic, 2004, 48.7%, etc. So it's important to note that you need to choose here whether you're graphing Democrat percentage or Republican, and please note that in your summary. I'm going to do Democratic percentage. So what I'm going to do is I'm going to be entering the X values of 0, 4, 8, 12, and 16. And my Y values are going to be 46.5, 48.7, 51.5, 50.7, and 43.6. So back on your handout, you should have a link to a Desmos. And when I open up this Desmos has my data in there. So you would be coming in and manipulating these values. So what you would be doing is coming in and entering new Y values. Note that mine says on the y-axis already percent of Democratic voters. So if you did Republican, I would just change this axis by going to these settings and making that percent of Republican voters. All right, what we are doing now is we're going to use a linear regression to like best predict. You'll see that I threw in a few different models. If you're curious, essentially all this is like saying y1 is approximately, and I used my like x1 to represent like all these x inputs, and it's going to give me an r squared. Now our r squared value means like how close does our line like, or how much variation is described. So the more variation or the closer to 1, the better. So if I look at my cubic regression, I notice that that's like a 0.99, which is almost 1. Whereas when I look at my other r squared values, they're like just like not that great. So I realize that like that's probably like not going to be, oh here, my quartic is actually pretty good. So I would click on, let's click on this, and I'm going to actually use this to map my data. So if I use that quartic regression, I would say, all right, this is predicting that in 2020, the vote is going to be about 29% Democratic. Now, if you're like, ooh, this feels like unrealistic because of that sharp curve, the other thing that you could do is you could add in a predictor. So in my table, I can add in a 20 for a new X. So that would be like the year 2020. And then for the new Y, I might add maybe something that's predicted. So let's say that this is predicted to go to Biden, but barely. So let's say that that value is like a 51. Now, that regression model might not be the best. It still might be the best, but we're going to go back and look and say, okay, now which model is the best? And if it still is indeed that same model, then you would again use that line to predict. Just because it goes through, like it's trying to go through that point, but just because it might not. So you might see that maybe cubic you think is best because this one tends to go up to infinity pretty quickly. So use some judgment here. After you get those values, you're just going to go back to your spreadsheet. I would screenshot an example and then go through here and like talk about your adjustment and then what your prediction changed to. Can't wait to see what you guys get.